This is question number 4 from the final exam from section 1.5. We have the problem says a tank contains 2,000 liter of solution consisting of 110 kilogram of salt dissolved in water. So salt and water mixed together is 2,000 liter here, where part of this 2,000 liter is of water is dissolved salt, and that amount is 110 kilogram of salt. It says pure water is pumped into the tank. So right now the water that is going to the tank is pure water. Since it's pure water, the concentration of salt in it is 0. Amount of salt per liter goes into the tank. The pure water is pumped into the tank at the rate of 7 liters per second. So this is going to be called CI, that is the concentration of the salt in water is going to be 0 gram of salt. 0, let me just rewrite this, that's pure water. So CI is the amount of concentration of salt, 0 gram per liter of salt goes into the water at the rate that is getting there is 7 liter every second. So after 1 second, there is 7 liter of pure water in here. And then once it enters, it gets mixed and is pumped out at the same rate. So then 7 liter gets in, 7 liter gets out. So that is R of out, rate of getting out is 7 liter every second as well. So that means this water is always going to be 2,000 liter because the same amount gets in and the same amount gets out. So that is the concentration of the water as it's getting out is going to be the concentration salt of the water that is getting out is unknown, is we call it X, that's the amount of salt per 2,000 liter. So that is the amount of salt per liter. Because the pure water gets in, so there is no longer going to be 110 kilogram of salt. Is going to be less as time goes by. How much is that salt that is getting out? It is X amount, we don't know, per 2,000. That is the amount of gram of salt per liter. That's called COO. So I did that because we know the formula for the amount of salt. X is the amount of salt, gram of salt. So the change of salt with respect to time is equal to RICI minus ROCO. So RI is 7 times CI is 0 minus what it exits is 7 liter times the concentration is X over 2,000. So 7 times 0 is 0. We get negative 7 over 2,000 X is equal to dx over dt. I'm going to cross multiply, I get 7 over 2,000 dt is equal to dx over x. So in other words, I'm trying to separate the terms. So I swapped these two. And you can do that when you have a rational equation we can move the dt to the top and x to the bottom. So this way, I can find the integral of both sides. I'm solving for x. I get natural log of x is equal to 7 over 2,000 t plus c. To solve for x, we are going to, well, and I didn't put the absolute value here because x is amount of salt and it cannot be negative. So I didn't put any absolute value. So anyways, we are going to, since natural log has a base e, we say x is equal to e to the power negative 7 over 2,000 t plus c. And we are going to solve for c. And before I solve for c, we know that if I have e to the power a plus c, I can write this as e to the power a times e to the power c, but that's a constant, so I get CEA. So I'm just going to get rid of that c and put it in here. So now, according to the amount of salt at the very, very beginning, at the start of the problem, when time was equal to 0, amount of salt was 110 kilogram. So I'm just going to put 110 kilogram. I know I said gram here. I can always change that to a kilogram of salt. Instead of 0 gram, I can say kilogram. Because I'm not using kilogram anywhere else, I'm not going to convert it. So when time is 0, the amount of salt is 110. I'm going to substitute 110 for x. C is unknown. E negative 7 over 2,000 times times t is equal to 0. So 0 times anything is 0. E to the power 0 is 1. That tells me c is equal to 110 kilogram. So x is 110. E to the power minus 7 over 10,000 to 2,000 t. So now it says, how long will it be until we have only 11 kilogram of salt in the tank? So now we want to find the time where when the salt amount is 11 kilograms. So we want to find the time when the amount of salt is 11 kilograms. So I'm just going to substitute 11 for x and solve for t. We are going to divide both sides by 110. Then I'm going to find the natural log of both sides. I get n of 11 over 110 equals to negative 7 over 2,000 t, because when I insert an ln on both sides, because it's an equation, I could insert ln on both sides. ln has a base e. Since the bases are the same, this goes away, and that's all I get. That's how I got that. And then I'm just going to divide both sides by the coefficient of t. And you have to put this in a calculator. So make sure you put that in, then division sign, then put parentheses around that if you're putting it in your calculator. Parentheses on the top, parentheses on the bottom, and you get t is equal to, after rounding, 658 seconds. So it takes 658 seconds for the amount of salt to become, or the concentration of the salt to become 11 kilograms.